In this video, we are going to be looking at section 2.3. 2.3 is the multiplication property of equality. So similar to the addition property of equality, whenever we deal with an operation, any non-zero quantity that is multiplied or divided on one side of the equation must similarly be multiplied or divided on the other to maintain equality. Again, consider a simple equation. 5 times 8 equals 40. Any change made to one side must be made identically to the other side to maintain equality. So 5 times 8 divided by 4 is equal to 40 divided by 4. So if we replace the 8 with an x, we can similarly divide both sides by 5. So if 5x equals 40, and we divide both sides by 8, we will get x equals 8, which we knew from the beginning. Whenever any non-zero quantity is multiplied or divided from one side, we must multiply or divide the same from the other side. This is called the multiplication property of equality. The multiplication property of equality states that if A equals B, then A times C is equal to B times C. When solving with this property, we must already have the variables on one side and the numbers on the other. This may require using the addition property first. So what this is saying is that you need to simplify and move everything with the x on one side of the equation, anything that does not have the x onto the other, and then use this property to get x by itself. Let's take a look at a couple examples. For example 1, 9x equals 27. So 9 times x equals 27. The 9 is being multiplied to x, so the opposite of multiplying is dividing. Let's show our division by writing it as a fraction. So again, since I divided by 9 on the left-hand side to get a 1x, which is just x, I have to divide the 27 by 9, so we get 3. And that one's fairly easy to see that 9 times 3 is 27. For example B, they have the x on the right-hand side, so we're going to look over there to see what's being done to it. We have negative 3x, which means negative 3 times x. So to get rid of the multiplication of negative 3, we'll divide by negative 3, which means, again, across the equal sign, we have to divide by negative 3 as well over there. 18 divided by negative 3 is negative 6. And then negative 3 divided by negative 3 is 1. So we're left with 1x, or just x. A couple more examples for us to look at. For C, we have 12 times x equals 6. So again, we look to the side with the x, and it's being multiplied by 12. So we need to get rid of the 12 by dividing. So we have to divide the other side by 12 as well. So the 12 divided by 12 becomes 1. So we have x equals, notice on the right-hand side we have 6/12. They're both multiples of 6, so we can simplify. 6 divided by 6 is 1. 12 divided by 6 is 2. So x equals 1/2. D, we're just dealing with decimals now. So let's get rid of our multiplying 1.5 times x by dividing 1.5 off. And so that means across the equal sign, we have to divide 7.5 divided by 1.5 as well. So again, 1.5 divided by 1.5 is 1. 1x equals x. And 7.5 divided by 1.5 is 5. So x equals 5. Now let's take a look at some fractions. Remember, to divide off a fraction, we're going to flip and multiply by the reciprocal. And so we have negative 2/3. So let's write it down here so I have more room. we're going to take it, and I look at it as the -2, since it's on the top, is being multiplied, so I need to divide it and move it to the bottom. And at the bottom of a fraction, it's like dividing, so I'm going to change it and multiply. So that's what my brain processes as I flip my fraction to be able to multiply. And so this side as well needs to be multiplied by the same thing, 3 over -2. So let's go ahead and put the 18 over 1. And then on our left-hand side, multiply by 3, divide by 3, cancel. Multiply by -2, divide by -2, cancel. They become 1. And if you look at it, we'll get -6 over -6, which is 1 if we think of just multiplying them. But we get x, either way you want to think of it. And then we have 18 over 1 times 3 over -2. Well, let's go ahead and simplify this to make our math a little easier. 18 and 2 are both even. 18 divided by 2 is 9. And 2 divided by 2 is 1. So we get 9 times 3, which is 27. And 1 times -1 is -1. So we need to keep that negative. And then since it's over 1, we do not need to put that denominator. So -2/3 times -27 is a positive 18. Don't forget, you can always check that by multiplying that in the calculator. Let's take a look at f now. We have x over 1/3 equals 5/6. Again, if you think of this as a fraction, you can think of it as x divided by 3 equals 5/6. So to get rid of a divide by 3, we're going to multiply by 3, which means we have to multiply the right-hand side by 3 as well. Multiply by 3 divided by 3 becomes 1. So we have a single x on this side. And then let's put our 3 over 1. So we can think of 3 as the numerator. And notice 3 and 6 are multiples of 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. So we're left with 5 times 1, or 5 on the top, and 2 times 1, or 2 on the bottom. So x equals 5/2 for f. Okay, now let's look at a couple more examples. For g, we have -3 times x equals 0. So let's get rid of the -3 by dividing it off. So we need -3 being divided on the right-hand side as well. And 0 divided by anything is 0. Don't forget 0 on the top, it's 0, 0 underneath, it's 0 undefined. H, we have -x equals 15. We saw that in the last lesson, that we can put our invisible 1 there, so it's the same as -1 times x. So we're going to get rid of that negative sign by dividing both sides by -1. And we get x equals -15. Now for I, we have a two-step algebra equation. Notice we have not just 3x by itself on the left-hand side, but we have 3x minus 7. So again, you need to get rid of all the adding and subtracting first. So anything with an x needs to be on one side. Anything that does not have an x has to be on the other side. So the -7 has to be taken care of before the times 3. So with the -7, we need to add 7, which means we need to go across the equal sign and add 7 as well. So now let's simplify. Doing -7 plus 7 zeros out, and we'll bring down our 3x and our equal sign, and then 32 plus 7 gives us 39. Now that we've gotten rid of our adding or subtracting, we can go to getting rid of that coefficient. We're getting rid of multiplying by 3 by dividing by 3. So our 3's going to turn into 1, so 1x equals 39 divided by 3, which is 13. And J looks like problems that we were dealing with in the last lesson. However, we're not going to get a single x when we combine our x terms, so we'll have to add that step of dividing off that coefficient. So let's take a look at what's going on. We have 9x minus 3 is equal to 5x plus 9. I mentioned last time that for me, I like to move the smaller of x's to the larger amounts. And so that means the 5x is the one that gets moved. So that means all my x's will be left on my left-hand side when I simplify that. And so 9 minus 5 is 4. So 4x simplifies there, and we'll bring down our minus 3 equals 5x minus 5x is where we zero out our x's on the right, and we'll bring down that positive 9. So now that we've taken care of all the x's going left, let's make our constants go right, which means our 3 needs to go. It's being subtracted, so we'll add it back on. And across the equal sign, we'll add 3 to the other side as well to keep it balanced. And when we zero out our minus 3 and plus 3 on the left-hand side, all we're left is that 4x. And then on the right, we'll add our 9 plus 3 to get 12. And so then our last step is to get rid of that 4 times x, so we'll divide it off. And of course, we have to divide it off on the other side as well to keep our principle of equality. And so we're left with x on the left-hand side, and 12 divided by 4 is 3. So x equals 3 for this example. Now K and L give us some other things. Notice they have it switched a little bit for K. We have our x's second instead of first. No biggie. When I look at my left-hand side, there's nothing to simplify. My right-hand side, there's nothing to simplify, so I can go ahead and start moving x's. My minus 2 is smaller than my plus 4 on my coefficients, and so I'll get rid of my negative 2 since it's smaller by adding 2x. Plus 2x on the right-hand side as well. Make sure that you're lining up like terms so you can properly combine them. Negative 2 plus 2 gives us 0, so 0x disappears, and we'll bring down our 11, and our 5 gets brought down, and then 4x plus 2x will combine for 6x. Now, since the x's went right, the constants need to go left, and so 5 needs to move. It's a positive 5, so we'll subtract it off. And so on the left-hand side, we have to subtract 5 as well. And on the right-hand side, 11 minus 5 leaves us 6. 5 minus 5 was our 0, so we'll leave that off. And we're left with plus 6x, or a positive 6x. And so our last step then is to get rid of the 6 that's being multiplied by the x by dividing it off. So we'll divide 6 to the other side as well. And we're left with 1 equals 1x, or 1 equals our x. And on L, we are in need of combining like terms. So remember, when we're dealing with this, don't do the opposites, because, for example, some people want to do minus 5x and then minus 5x here to try and combine them. But if you see, I drew a line across the equal sign to show you we subtracted 5x twice from the left-hand side. We didn't do anything on the right-hand side, so that's throwing it off. It's not keeping it equal. And if we do that, we're going to get the wrong answer. So when we're combining like terms, it might be helpful just to put them next to each other. So we have our 2x on this side, and we have a positive 5x, and we have our plus 1. So then we can see that we're combining 2 plus 5 to give us 7. So 7x plus 1 on this side. And then the minus 4 and minus 7 to combine on the right-hand side are already next to each other. So we have our x, and 7 and 4 is 11, so we have minus 11 there. Since the signs are the same, I added and kept the sign. So now we have the left-hand side simplified and the right-hand side simplified. So let's move x's. 1 is smaller than 7, so I'll take care of the 1x by subtracting 1x from both sides. 7 minus 1 leaves me 6, so we have 6x. Bring down my plus 1. On the side, 1 minus 1 is 0, and we'll bring down our negative 11. Again, don't forget to bring that sign down. That's an issue that I have often. Now that we have our x's on the left, our constants need to go right, so our plus 1 needs to be moved. So let's change it to minus 1, so we'll zero it out. And minus 1 also goes on the other side of our equal sign. And now that we've done that, we can simplify again. Our 6x gets brought down. 1 minus 1 is 0. And we have negative 11, subtracting 1 more. So we'll get negative 12. And now we're left with x's on the left, constants on the right. And our last step is to divide off the coefficient if it's there, which is our 6. So we get rid of our multiplying by 6 by dividing by 6 to leave us with x on that side. And negative 12 divided by 6 is negative 2. So that's enough of practicing together. It's time for you to practice on your own. The practice problems for this section are on pages 59 and 60. It does give you some word problems to deal with, so if you have any difficulty with those or any of the other problems, don't hesitate to let me know. Remember, if you're watching this because you missed class, then you need to show me that you completed the practice problems for the section so you get credit for that for your workbook grade. I'll see you next time.